on it over
Okay.
Teams.
And I'm going to share my screen. I hope. Yes. Hannah, can you confirm that you can see
Yeah,
it? It
I
looks like
can
you
see
can.
it.
Okay,
Yes.
I will not be able to pay attention to the chat during this, so please just interrupt Hannah if something comes up you need to stop me or something. I'll be off in a world of my own. It's the most philosopher thing I do. Um, Hi everyone. I'm really glad to be back. I'm giving a talk, an updated version of a talk I gave last year that I try to give everywhere I can. And part of the point or the goal of this talk is to get people to see the real hurdle we face in trying to responsibly design, develop, deploy, and even do research on AI and big data analytics systems. So that's my goal here, is to motivate a particular kind of approach that we're not currently well oriented towards achieving. And I hope to at the end say some things about what to do given that we don't have that. It's meant to really orient like what we should be advocating for, what we really need in this space to manage AI ethics or to manage AI issues. But I think there's also some smaller stage things that people can do besides advocate for that larger solution. And I'm happy a lot of that will come out in the Q&A, I think. Okay, so I want to start by saying something about where we are. And where we are is if you follow tech news or the news generally, you'll see lots of stories about failures in the tech space. But the failures aren't just, for a while, it was lots of like not ill meaning, but companies that weren't even trying to do AI ethics responsibly in any kind of way. And they would do something and they'd get criticized for it because they just failed to consider some obvious thing. But now we're seeing, even as people continue to try to responsibly develop these technologies, we still keep seeing failures. So this is a result from a Gemini, which is a Gemini Google's Gemini image generation system. Someone asked it to output Nazis, a photo of Nazis, and it output Nazis, minority Nazis. And they got yelled at for this. And of course, what they said was they were trying to combat a different problem, which is if you typically ask these image generators to generate images of people, they only generate white dudes, or they predominantly generate white dudes for totally unsurprising reason that they just those images dominate. And our training data was poorly in many image generators was poorly cultivated. So they were trying to manage that problem. So they were actually trying to do the right thing and make sure that we got representative images when we called for these search results. But then we face this other problem is sometimes we actually want things that are historically accurate, and it does a bad job of that, and that's a really hard problem to resolve technically. They got called woke by some people for having a system that tried to remove white people or to not only generate white people. So it was a whole controversy. Even though I know a bunch of the teams there that worked on the research on this, they were really trying to make the tech work well, but they still failed. And that's part of a broader set of failures. We just don't really have unified terminology. Um, we don't have any concepts we agree on. We're still like sort of giving high, where everyone agrees to a bunch of ethics principles, like we want fair, private, transparent, autonomy, respecting AI. But like what that means in practice, we're not really there. And so we're still really struggling. And so, what I want to start doing in this talk is diagnosing and giving examples of four kinds of ethical sort of missteps we continue to make despite trying our best in many ways, um, and use that to motivate a view about what we need to aim at if we actually want to solve them. So, I'm going to talk through four what I'm going to call pain points or problems or recurring mistakes. The first is misapplication of existing tools where we want to solve a problem that we've otherwise solved elsewhere. And so we just take the tools we use to solve them elsewhere and apply them in the AI space, but they fail us. And there I'm going to talk about privacy and informed consent from bioethics. The second kind of problem that we continue to face is technical insensitivity. And that's when people like me, ethicists, try to bring their ethics toolkit to these problems, but they fail to understand the underlying technologies. And so they offer really bad advice. There, I'm going to talk a little bit about large language models, but primarily I'm going to talk about autonomous vehicle ethics or autonomous vehicles. Then there's the third kind of mistake, which is recurring, which is what I'm going to call normative ethical insensitivity. I'm not, I want to be very clear. I'm not claiming any of the practitioners that I'm going to criticize in any way don't care about ethics or don't want to do the right thing, but they just like the philosophers lack the technical expertise to mold their tools to purpose. Lots of people lack like ethics. There are experts in ethics. There are people who know about ethics toolkits, and the lack of understanding the ethical dimensions of problems in a really deep, nuanced way causes the creation of technical tools which just miss the mark. There, I'm going to talk a little bit about algorithmic fairness and algorithmic opacity. And then the fourth category of mistake is lack of stakeholder engagement, just failure to engage appropriately with key stakeholders. There, I'm going to talk a little bit about Google and Apple's contact tracing app. I'm actually going to go not in that order. I'm going to talk about the first one and the fourth one because I can get through them pretty quickly. And then I'm going to spend a little more time on 2 and 3 that take a little more time before I use these as tools for drawing a broader lesson. So let's start with off-the-shelf toolkits. So informed consent and anonymization are tools that we use. They're practical tools that inform the everyday practice of people doing, for example, human subjects research or clinical research. And they're tools that were designed to, they're not foundational values. Nobody thinks that the fundamental moral principle of the world is to get informed consent or to anonymize personal identifiers. Instead, those are tools we came up with to protect the things that are foundational values. So we said, like, hey, what does it mean to show respect for persons? Well, part of showing respect for persons means promoting and protecting people's autonomy. Okay, what practical tools can we use to promote and protect people's autonomy? Oh, informed consent. We can make sure that we explain things carefully to them, that they understand it, that we don't coerce them, that they agree to it. And we can do our best to anonymize them so we can't peer into their lives after the fact. We can't figure out who they are or track them down or otherwise invade their privacy. We can't learn sensitive characteristics about them, like that they have a particular disease or that they have a sexually transmitted disease. We know that they're in our study. We want to study them, but we want to know personal features about their life. And if we anonymize them and give them just a random identifier, we can do that. Now, in the AI context, we want to promote and protect similar values. We want to show respect for persons. We want to promote and protect autonomy. And so it just seems very clear. Why don't we just use the same tools? The problem is, when we deployed and developed those tools in the biomedical context, we carefully designed them to make sure that they realize those values. You can't just take the tool off the shelf, deploy it, and hope it'll actually promote those values. So let's talk about just the way those fails in this context. In the big data analytics context, there's no way to actually do informed consent as in the clinical research context. You're trying to deploy tools that will analyze millions and millions of data points. A lot of these tools are online and collecting online trace data. So you're not going to be able to sit down in a one-on-one situation and sort of say, like, here's how we're going to use your data. Here's what it means for you. And can you consent? So there's 3 components to consent: disclosing the right information, ensuring understanding, and then getting a token of non-coerced consent. Notice and consent really fails at all of those. Like, the notice typically comes in the form of legalese. Nobody can understand it. You do satisfy disclosure, I guess, because you just disclose everything, but it's really technical and hard to follow. And it's not clear that it's not coerced. Like, many of you are here on Zoom or you use Teams in your organization. Like, you have to opt into that data collection in order to be a part of your job. So it's in some sense not totally consensual. So like, that tool has been changed in such a way that it no longer realizes those values in any way. It doesn't really promote and protect autonomy. It just covers legal ass, to put it mildly. Anonymization. Here, it's not a change in the tool. Anonymization has been largely adopted for big data analytics practices. It's the anonymization of personal identifiers. So things like name, birth date, social security number, things like that. But that works great in small scale clinical contexts. But in big data analytics context, Facebook Meta does not need to know your name or your birth certificate to attach a random identifier to you and make reliable inferences about your preferences and who you are and manipulate you. So anonymization just doesn't serve the function of protecting autonomy in the context of big data analytics. So we can't just take tools off the shelf, which we do all the time because it's, of course, a big time saver and it seems like it would be a great thing to do, and hope that they'll protect the same values. Let me now say something about lack of stakeholder engagement. So I don't know if any of you know that Apple and Google co-developed, along with states, a COVID contact tracing app. And it is really technically amazing. It does such a good job of protecting your privacy. I really think they pretty much nailed it. Like, Google or Apple never has access to your location data. Like, your phone knows when it was near another phone, and they send a bunch of data up to Google that doesn't actually learn anything except that there were 2 phones near each other, but not where they were. And if one of them, test positive and they put that they test positive, it can send a message to the other phone so the other phone knows it test positive. But those 2 people can never figure out who they are. Like, they don't know who they were next to. They just know that they've been exposed. They really did a good job. It will be unsurprising to you, I mean, we lived through it, that this did not succeed. Like some people, I had the contact tracing app. Some states signed on, but not all states. It was very slow to roll out. There was low acceptance. Um, and the reason for that is partially, I mean, the initial problem was always going to be distrust. Nobody trusts Google. People trust Google the least. Well, it's a toss up between Google and the states and then maybe Apple. But the parties involved were not very trustworthy. And not only that, the details of how they were protecting privacy were buried in technical documents that nobody could read. If they could explain to stakeholders in a clear way how the technology had worked and the ways in which it was privacy preserving and designed to respond to their biggest fears, that it plausibly would have had much greater uptake. Okay. Third problem, technical insensitivity. There's technical insensitivity in users. For example, many of you may have seen the story where a lawyer generated a brief using ChatGPT. He submitted it. The judge went to look for some of the case law, I think, but the case law was completely fabricated. It just made up citations. And so the judge said, "Where are these citations?" The person said, "Oh, I don't know, that the thing generated them." He thought it was like Google, where it was going to be accurate, like Google used to be, and less so now. And he got in trouble. And so, like, just not understanding that ChatGPT generates random tokens of text and is likely to be wrong all the time. It's hallucin. We can talk about it. I don't actually think it's hallucinating. I think it's always hallucinating, but they're called hallucinations. So that's one kind of technical insensitivity, not understanding how the technology works in a way that doesn't let you deploy it responsibly. But even those that theorize about it, like me, philosophers, hopefully not me in particular, but people like me, also fail to understand the details. So here's an image from MIT's Moral Machine, which was a project to get people's views about how autonomous vehicles should behave in so-called accident scenarios. Now, this came about because I don't exactly know the origin of this, but all of a sudden there were a bunch of news articles about comparing accident scenarios involving autonomous vehicles to so-called trolley cases from philosophy. A train is running down the tracks. It's going to hit 5 people. If you pull a switch, it'll divert and kill one. And we can ask, what should the person next to the switch do? These are famous thought experiment philosophy. You use them to test a bunch of different hypotheses about moral principles. Someone had the bright idea that these things looked a lot like accident scenarios that cars might be in. And they said, hey, and for the first time in forever, philosophers were relevant. People were calling us up and saying, hey, can you tell us how to use trolley problems to solve these real world problems? And we got very excited about it. And it launched a whole bunch of research programs with people trying to discern whether we should or shouldn't use these tools. I'll sort of, just to make sure we get through all the content, won't say much more about it, except I won't trace the debate, but I'll say something about why the sort of technical insensitivity was driving this whole debate in the first place. There's this whole literature on it, largely insensitive to the technical details. To see why, we got to draw a distinction between traditional ways of control, what I might call traditional paradigm for developing algorithms, versus the machine learning paradigm. The traditional mental model we have of how we create an algorithm, which is just a mapping of input to outputs. An algorithm tells you, an algorithm transforms some kind of input, like I push the letter A on my keyboard, to an output, and A appears in the document I'm typing. That's an algorithm that transforms typing inputs to visual inputs in a document or something like that. In a traditional paradigm, what we do is a programmer designs every step of the way how we get from input to output. So they say, when someone pushes A, this feature, this happens, this happens, this happens, and ultimately this output comes out. Okay, that's the traditional paradigm. In the machine learning paradigm, that is not what we do. What we do is we take a learning algorithm and we give it a bunch of examples, many thousands of examples, and we have it generate the algorithm. So we have a learning algorithm that itself generates an algorithm. And what we do is a lot closer to how you train a dog. When you're training a dog, you don't sort of get to do neuroscience and say, like, when you hear sit, put your butt on the ground. Instead, we sort of get it to sit and then we give it a reward. We get it to sit, we give it a reward. And eventually what we hope is that when it hears sit, it puts its butts on the, it learned to put its butt on the ground. That's kind of a good mental model for machine learning. In the case of autonomous vehicles, you cannot make an autonomous vehicle according to using fully the traditional paradigm. I won't get into details, although I'm happy to talk about them in the Q&A, especially in object recognition. We're just not, it's like trying to manage the problem of spam. You can't write the rules for classifying any given email as spam. It's much easier to just have thousands of examples and have the program learn what spam is. Same here. Like, getting a thing to recognize a double yellow line, or getting a camera to recognize a stop sign or a speed limit sign, or the different road signs and different kinds of objects, is a really hard programming problem on the traditional paradigm. But it's relatively simple if you have a huge, it's not that simple, but it's a much more tractable problem if you have a huge amount of data and you use a machine learning approach. Okay, why does that matter? When you're in the machine learning paradigm, unlike in the other paradigm, you can't think about how to get particular behaviors in particular scenarios directly. You have to think about how to train for the individual behaviors in particular scenarios. Okay. But you have to train for all the scenarios the car is going to be in. So you have to ask questions like this: how much of my training should be dedicated to recognizing everyday driving scenarios and how to behave in those, versus how much of my training should be dedicated to managing accident scenarios? Now, notice that that's a different question from how a car should behave in any given scenario. It's how should it behave across scenarios? Notice also that that's an ethical question. How should I train my car? How should I train my dog if I can only have a limited amount of time and I can dedicate some training to potty training and some training to behavioral training, or something like that? Like, how do I allocate my resources? Okay. Those are different questions. And so the relevant ethical questions for machine learning contexts are about training regimes and data cultivation and those kinds of things. So the mistake the philosophers made was thinking you could program these things in the traditional way. And so therefore the ethical question was about individual behaviors, as if we could just train for one behavior or we could just program for one behavior at a time. So they ultimately gave a lot of bad advice, saying like, oh, you should use trolley cases for this, this, or this, which is actionable advice. Engineers can do it. They'll just say, oh, I guess I have to build a training regime to make sure the car does this in this situation. But in doing that, you're making decisions that affect how it behaves in other cases. You're making assumptions about trade-offs that are maybe unwarranted. Okay. So that's the way the philosophers have failed us. It's the only time it's ever happened, I promise. Now let me transition to ethical insensitivity. Just as the philosophers have failed to sort of fully appreciate the technical details, many people have failed to appreciate the ethical details, the nuances of ethics that are necessary deploying technology responsibly. And I'm going to talk very quickly through two examples. In fact, maybe I'll just focus on fairness because it's the most well known, but it is true in opacity. It's largely true in privacy. So on this slide, there's a black box which represents transparency, and then there's this image from this article by ProPublica on the Compass recidivism prediction tool that was developed by Northpoint. This company released this tool. Compass did an analysis and claimed that it was disproportionately labeling Black defendants high risk. It was disproportionately mislabeling Black defendants. In particular, it had higher false positive rates for Black defendants. They were getting labeled high risk and then not reoffending at a higher rate than white defendants that were labeled high risk. So they accused it of being unfair. Northpoint came back and said, well, actually, we did calibrate this. So they have a different condition of fairness. It's called calibration. We can get into the math in the Q&A if people want to. But the real thing here is that what they thought was, oh, we have a metric for fairness. It's a measure of how outcomes are distributed. And we just have to figure out what the right one is, and then we can just implement it technically. So ProPublica claimed it was one thing, Northpoint claimed it was another, but the real question is just what's the right metric? But this totally misses a bunch of important facts about fairness. Like, not all fairness is a function of distributions. Like, we shouldn't only care about whether distributions are fair. Sometimes what we care is about procedural fairness. Was the process fair? Like, when we think about what a fair criminal trial is, the question is, did we give enough guilty verdicts? Or did people of a particular race get enough innocent verdicts? No, we want to know whether the process is fair. Was it insensitive to race, for example? Because that's not something the process should care about when convicting of a felony. Also, there's restitutive accounts of fairness. Like, sometimes we owe non-equal distributions for failures in the past. So like the justification for affirmative action is not legally, but often morally, is something like, we actually disadvantaged a group of people significantly in the past, and so affirmative action is meant to respond to that. But that means you're not trying to achieve fair outcome. You're not trying to achieve equal outcomes. You're trying to address a past unfairness. So what the right fairness metric is, or whether it's appropriate to use a fairness metric, is entirely contextual. And figuring out which context calls for either which measure or whether no measure is appropriate is a real nuanced ethical problem that there's lots of resources and tools and things in ethics that can help us resolve that question. The same, I'll just say quickly, is true in transparency. There are many algorithms which we don't understand how it transforms inputs to outputs. Like it's just a mystery to us. ChatGPT or LLMs are one example, but there are lots of these things. They just have too many variables they're taking into account, and we can't figure out how they're getting from input to output. This seems problematic for some people. There's something problematic about making decisions about people, especially high stakes decisions, without being able to explain why that decision was made or not knowing how it was made. But it's actually really complicated to explain why that kind of transparency is justified. And as we work through that problem and figure out, like, so some people want to say, you need to make sure algorithms are transparent because we owe people explanations for why we make decisions about them. But that's not obviously true. Hiring decisions we don't explain to job applicants. It'd be very strange if we had to explain surveillance decisions to the person we're surveilling. It would kind of defeat the purpose. Instead, there's other reasons we might worry about black boxes. Namely, it interferes with my ability to reason about you in particular ways. When I'm deciding who to surveil, there's certain things I should count as evidence, and there's certain things I should not count as evidence as a reason to surveil someone. Or when we deny someone a job, we want to make sure we're not thinking about things like gender or race. But it's not about explaining it to them. It's to make sure that I'm reasoning in a particular way when I'm making good decisions. And black boxes can interfere with that. The reasons we have for being transparent will change what it means to open up the black box. There are different tools we can use to unpack how the black box algorithm is working. Happy to talk about that in the Q&A as well. But which one we use is a deep, hard ethical question, and you need ethical expertise to answer. You can't just crank out a technical solution, which is basically what's happened. We have XAI techniques that will just generate explanations of how the black box algorithm works. Okay, so what should we learn from these 4 pain points? Like, here's some lessons you might take away. It's really important that people understand the technology that they're deploying, or theorizing about, or offering ethical advice about. It's really important to make sure technical solutions aren't normatively free-floating, that they're deeply connected up with hard ethical concepts, that we use good ethical tools to think about them. We should definitely keep context in mind. We should realize that different contexts call for different ethical values and ethical principles, and make sure we're keeping that in mind. We should think in terms of socio-technical systems and not just technical systems. We shouldn't just look for a technical solution. We should recognize that algorithms are parts of social systems, and the solutions might be socio-technical. And we should be sure to engage key stakeholders. Those are all lessons you might draw from the pain points. No, that is not the lesson I want you to take away from here. I mean, those are all good insights. I don't want to disparage any of them, but it is in some sense deeply optimistic, and that's putting it nicely, to expect that all the stakeholders in the space can take responsibility for having all the levels of ethical, technical expertise, for ensuring broad stakeholder engagement, for expecting the public to be engaged enough to be able to advocate for their values, to understand exactly how a tool is going to fit in a particular context. That is a huge amount of work. Like, I've met enough philosophers to know you're not going to get all the ones that are going to say things about AI ethics to understand technology. It's not going to happen. Instead, and another note, that is not how we manage technology in any other domain where we manage it responsibly. Instead, in all other domains, we use what I'm going to call an ethics ecosystem, which is a coordinated system of components that distributes the task and responsibility of doing ethics. I'm just going to talk through what these are, and then I'm going to give you a comparison of what we've got in other places compared to where we are in AI ethics. So the key components are this, I think. Ethics infrastructure. That's the everyday tools and toolkits that people can use, the checklist to make sure that they're doing ethics in their domain. They're operationalizations, and there's local oversight, the people checking to make sure it's done appropriately. Sort of the day-to-day stuff we do to make that sort of helps prevent an unethical use or accidental problems. Then there's the training, education, enculturation, and outreach. And by that, I mean training people, for example, how to use those everyday tools and toolkits, right? Like teaching them when they should stop using the toolkit and go see outside help. Outreach, being able to explain to the public how the toolkit, how the ecosystem functions to protect key values. A key part of the ecosystem is enculturation. When people are part of an ethics ecosystem and we do train them enough and we constantly talk about the values and the ways that we're supposed to use the toolkit, it becomes part of the way they see the world when they're engaged in that ecosystem. So it just becomes a part of their life that they view problems from the lens of that ecosystem, and it makes it possible for them to not only carry out the functions, but to sort of elevate or escalate or seek help. And also to take on a sense of responsibility for doing that work. Another key part is informed policy and regulation, providing the incentives and the punishments to make sure people follow the day-to-day operationalizations and to in reinforcing doing that education and satisfying any training requirements. Interdisciplinary practice, making sure there's enough coordination between people of different disciplines or with different expertise to make sure that the right people are in the right room when you have to make important decisions. Another key component is what I'm going to call foundational to translational research. No ecosystem has all its ethical problems solved. There are some thorny issues everywhere. So we need people that are doing research on those thorny issues and the related deep philosophical issues or other empirical issues that need to be resolved. And then other people, those people or other people, that then translate that out to the ecosystem. They revise education. They push the ecosystem in new directions. They transform those day-to-day operations in better ways. And then there at the center of the ecosystem is a shared language and shared concepts that people can use to talk in the ecosystem in a meaningful way. And interdisciplinary practitioners and scholars, people who sort of don't belong in any single component of the ecosystem, but can facilitate communication across it. Now, that's pretty abstract. So let me get a little more concrete by doing a comparison of the ethics ecosystems available in healthcare versus where we are in AI and big data. So in healthcare, we actually have four, I only listed three sub ecosystems. The first is human subject research, clinical research involving human subjects. The second is animal subject research. When the US, the guidelines apply to any vertebrate animals. And then there's clinical care, like working with individual patients. There's another one, which was a really fascinating case, which isn't really enshrined in law, but there's different incentive structure, and that's embryonic stem cell research. Happy to talk about that in the Q&A, but that's a separate one. And I want to point out, I'm only talking about healthcare because it's the one I know best. There are ethics ecosystems in all other deployments of technology. Law has an ethics ecosystem, and law is just a kind of technology. The military has an ethics ecosystem for how it deploys its technologies. Engineering has an ethics ecosystem. I don't love it, but I do really like aviation and civil engineering's ethics ecosystem. It's very one-dimensional. It's very safety-oriented, but it's got all the components. And I think there's like the one area that doesn't seem to have an ethics ecosystem at all is computer science, which is kind of part of the problem here. It's not the only problem because an ethics ecosystem, you can't just deploy one ethics ecosystem developed in one context to another. But it would have helped if computer science had one in the first place. Okay, so let's talk about the ethics infrastructure of healthcare. There are standard protocols that people doing human subjects research, animal subject research, and clinical care know to follow. They know how to fill out a particular kind of form if they want to do a certain kind of research. That research is overseen locally by, in the case of human subjects, an IRB, Institutional Review Board. In the case of animal care, animals, an Institutional Animal Care and Use Committee. In the case of clinical care, there's typically an ethics committee that sort of does the work of managing hard cases and providing guidance and feedback and oversight. In the AI case, we do not have anything that structured. So the closest thing we have in the US is the NIST AI Risk Management Framework from the National Institute for Standards and Technology. It's a really lovely document in many ways. It's really responsive to the ethical issues, but it's also very high level. It sort of says the kinds of things you need to manage ethical issues, but it doesn't provide the day-to-day operationalizations that someone could actually follow it. So like an organization picking up the ARMF has a ton of work to do in a way that that's not true in the healthcare context. Policy and regulation, both all kinds of healthcare research have enshrined in law, except for embryonic stem cell research for the most part, have enshrined in law requirements to have an IRB, requirements to follow those protocols, requirements to have certain trainings. It's grounded in the Common Rule for human subject research and the Animal Welfare Act for animal subject research. I know less about clinical care and what the laws are that govern that. In the AI and big data space, we have Biden's executive order, and we have this initiative grounded in the executive order to develop the AI Safety Institute. The AI Safety Institute is going to be a consortium, and it's going to be standards oriented. So trying to come up with standards for responsible AI development, deployment, and research that people agree to adopt. They have to agree to adopt it because we don't expect that there will be anything binding in law. But of course, that's not ideal because if you want people to buy in, you have to let them have a seat at a table. So it will not surprise you that the AISI has many members that have an interest in the tools being profitable in certain kinds of ways. So like Google is part of the AISI. Even though I'm not meant to disparage the AISI, it's just not going to have the teeth of law. There are state and city statutes on algorithmic decision systems. Many of these are unenforceable or unenforced, or many of them are vague in ways that it's not clear whether they're being violated or not. So it remains to be seen how much teeth they'll have. Outreach training, education, and enculturation. Just required trainings from the time you declare you're going into medical school or medical science. You start learning the ethics ecosystem. There are curriculum requirements in college. There's required trainings once you finish. There's you have to regularly certify with the IRB and get retrained. There are disclosure requirements that you have to show that everyone on your research team has satisfied the training requirements. In AI and big data, hi, you're getting it. Welcome to the outreach and training for AI ethics. There are big movements to do more tech ethics training. So the embedded ethics curricula led out of Harvard University is one model where you have integrated ethics training in computer science curricula. We do that kind of ethics training at Northeastern. I think it's important, but I'll say this about it. First of all, only elite institutions currently implement it in any serious or deep way or robust way. And it is totally uncoordinated from any other component of this ecosystem. No embedded ethics curricula talks about the NIST ARMF or tells people how they might go to a job that implements the ARMF and how the tools they're developing in that class or their curricula will help them carry out the ARMF, if it will. Interdisciplinary practice, easy to say. It's just standard in all the healthcare contexts. There's groups of different disciplines working together constantly. That just doesn't really happen in AI and big data. It's getting better. Research programs. There's a research field called bioethics, which just tries to solve the problems of bioethics. There are case study repositories for IRBs to use and sort of study. There are IRB conferences for exchanging best practices and getting insights from bioethics into the ecosystem. Not only that, but like publications in the journal Bioethics count towards the career of researchers in a way that it's not true if you do AI ethics and you're a philosopher, for example. There are journals. There are new AI and ethics, philosophy and technology. There are conferences that are interdisciplinary. FACT is one of them, and AIES. There's hiring trends. There's more demand for people that know something about AI ethics. But these are all sort of fledgling. Even FACT, which is the biggest interdisciplinary conference in AI ethics, you go to FACT and there's lots of disciplines, but then you go hang out with your philosopher friends or your social science friends or your policy friends. There's less interdisciplinarity than you'd see at other kinds of conferences that have developed ecosystems. And then when it comes to shared language and interdisciplinary scholars, this is robust in healthcare. Like everybody knows that those three components of informed consent that's working in human subjects research. Exempt research means something very specific that anyone here that works in clinical research knows what it means or like has to deal with an IRB. And it doesn't mean what it seems like it means on its face. And there are genuine bioethicists, like people who are interdisciplinary scholars. They're not doctors, they're not lawyers, they're not philosophers, they're bioethicists, and they can speak across the ecosystem. In the case of AI and big data, when I get in a room with a computer scientist, we have to spend a lot of time calibrating. What is fairness? What do you mean by transparency? What do you mean by privacy? There's genuinely very few AI ethicists. Like I don't think of myself as an AI ethicist because I know a lot about the technical stuff, but not enough to sort of claim interdisciplinary expertise. There's a young generation of scholars that I think fit that mold, but it's a very small group. You could fit them in a large classroom, I think. The number of people that claim to be AI ethicists, that you can't fit that in a classroom, but okay. So the lesson is that like that's the kind of thing we need to aim at. We need to aim at this robust ecosystem, and we're nowhere near that. Now that sounds pretty bad. How do you get there? And especially what do you do in the interim? One example I like to give, I work on this project called the National Internet Observatory, which collects users' digital trace data. So basically everything they do on the internet, we consent people and collect it. And then the idea of NEO is to make that available to researchers. Currently, if researchers want to study how platforms influence human behavior.
Oh,
Yeah, I'm right at time.
oh no, I thought I think you dropped out just for a second, but
Oh,
it might be my internet actually.
okay. Well, someone remind me if I missed something, I'll go back over it. So NEO collects all this data and makes it available to researchers so they don't have to like scrape Twitter or ask the internet platforms for the data that would let us study how they're influencing human behavior. Of course, this is sensitive data, people's internet behavior. So we've gone ahead and built our own little mini ethics ecosystem for this project. Because we weren't happy with anything that's out there and we actually think you need all these components. I won't go through the details. I want to leave a lot of time for Q&A. But you can find this paper in computational science, Nature Computational Science, that outlines all the components, the Swiss cheese model we built, and the ways we try to achieve the components of that ecosystem at the small scale. Now, unfortunately, I think we're at a spot where we need to build at the small scale. We need to act locally and think globally. We need to advocate for an ecosystem. We need to make sure we have an eye on what's going on in the different components. At the same time, we need to bring in the human capacity to sort of solve these problems at a local level. So we need to do what we can to identify what kinds of ethic infrastructure and tools and guidance are available to adapt to our context. But we need to recognize that we don't have, all of us, the expertise to do that. And so we need to advocate really for the human infrastructure to do it. So we need to build, in the meantime, until we have an ethics ecosystem, we should be advocating for one and contributing to it where we can. But otherwise, I think the key lesson is that we need to really bring in the right people to sort of build a mini one for us, just for the context we're thinking about. So there's lots of tools out there. I just put up one that I co-wrote, building data and AI ethics committees, which tells you how to think about the process of building a responsive community. Make sure, how do you empower them? How do you give them decision-making authority? But even if you take that guide, it doesn't necessarily mean you'll have the people to build that committee. So I think a part of the thing is we have to just invest in people. That's a double-edged sword, both because it's hard to get headcount at any organization, and it's hard to find money for that specific thing, especially ethics, trust me. But also the expertise doesn't exist. And so I think there's a lot of experimenting to do, and we have to try a lot of things in the interim. Happy to say more about things you can do in the interim, but I think I'll stop there. Thanks.
Thank you so much, John. Let me just take this off recording as promised.